Okay, this is the answers to the first part of your test. Not the best quality video because I couldn't work out how to do it, but here on my laptop screen you'll see the question. Here's the first question, using Kirchhoffs laws to find the bit inside the dotted loop, and then I have my notes, solutions handwritten. So it says V equals IR. It says the same V down each route, so same product of IR, since it's V down, each route must have the same V, whatever it is, less than 6 volts, let's say 4, it has to have the same V down each route, so I2 times 3 must equal I3 times 4. So I said 3I2 equals 4I3, rearrange 0 equals 4I3 minus 3I2. So that was question 1. Question 2 was this loop. It's loop scenario, so current is coming out the positive terminal, flowing around that way, so current is kind of flowing that way, which is kind of into the paper, from this north to this south, so field is going across. We have a current creating movement, so we're dealing with a motor, so we're dealing with the left-hand rule. When you marry up left-hand rule to be second finger current, first finger field, you can see my thumb is pointing down the screen, which best match is C. Here's my handwritten thing of it. Motor equals left-hand rule, current out of positive end of the cell, so going into the paper, field from left to right, so movement down. Then we look at question 3. A length of wire L is used in an electric heater when a potential difference across the wire is 200 volts, the power dissipated is 1000 watts. The same potential difference of 200 volts is applied across a second similar wire of length 2L. What's the power dissipated? Well, if the length gets 2 times bigger, then the resistance gets 2 times bigger, because it's twice the length. Therefore, the current becomes half. You've got the same, let's show you this, you've got the same voltage, therefore P equals IV is going to be halved, because V is the same but I's half, so P's half, yeah? So P's half, which is down from 1000 down to 500, so that's question 3. Whoop, nearly dropped my phone. Question 4 is this one. What charge has it got and what's the speed of it? Well, again, we've got a motor effect, haven't we? We've got a current creating movement, and it says that the field is directed into the page, so first finger field is into page and the thumb is going down, which means conventional current is pointing towards the left, which means that that thing moving that way is going the opposite way to conventional current, so it is an electron, so it has a negative charge. And then for the formula part, I did F equals QVB sine theta. Sine theta is theta's 90 degrees, so sine theta is 1, so got rid of that. F equals QVB. I did F equals mv squared over R. Married up the two F's to be QVB equals mv squared over R. Cancelled the V's, we got QB equals mv over R, sorry. Rearranged V equals QBR over M. So it was A or B. And then the first bit narrowed it down to A or D, didn't it? The fact that it was negative meant that it was, B or C, and then this equation is correct, so it's B. I messed that up a bit then, didn't I? First part, hand rule, says that the charge is negative, it's an electron. Second part, formula, says that this is the correct formula. I'll just hover over that because I feel like I messed up the explanation of that a little bit. You can see my first chain of thought, motor field into page, motion down, therefore current to the left, so charge is negative, so I dropped that, that's why I did it wrong. Charge is negative because it's an electron, therefore it's B or C. And then this setup here says it's A or B, therefore it's B. Yeah, I did that wrong the first time, that's why. Question 5. Two copper wires X and Y connected in series. The diameter of Y is double that of X. The drift speed in X is V. What is the drift speed in Y? Okay, so I got this wrong initially. I spent ages and ages going over it because I was thinking current. We are not talking current. We are talking drift speed. So if we go to our equation here, current remains the same. So A and V, because current has to be the same everywhere in a series circuit, doesn't it? So current is fixed effectively. So whatever you do to A, you're going to do the opposite to V. So A gets twice as big. Because A equals pi r squared, then, if diameter gets doubled, then the area becomes a quarter. So A gets 4 times smaller, therefore V needs to get, A gets 4 times bigger, therefore V needs to get 4 times smaller. Yeah? Does that make sense? Current is fixed. You make the diameter twice as big, so you make R 2 times bigger, which means you make A 4 times bigger, so this goes up by 4, which means that has to go down by 4. You can't change N and you can't change Q, they're kind of fixed inside a circuit, aren't they? Question 6. I went down the wrong route with this, and then I realised that we were dealing with the centres here, so that's R. So initially I thought, oh, it's halfway between them, R is D, but no, it's not. R is not D. You need to do this. If this is the 4 charges, you've got 2D, so halfway is D, D. So I said R squared equals D squared plus D squared, Pythagoras. Therefore, R is the square root of 2 times D squared. So R equals square root of 2D, right? So then I took electric potential is KQQR. Q is 1, therefore electric potential is KQ over R. Sub D into that, we get electric potential is KQ over root 2 times D. There's 4 of them, so it needs to get 4 times bigger. So I said 4KQ root 2 over D. And then I spotted this connection. You immediately rule out A and B when you do this. And then you kind of rule out C because you're like, well, the root 2 should be underneath, not on top. And actually, 4 over root 2 is 2 root 2. So that's where we came to D as our answer for question 6. I'm touching the screen like it's a touch screen. Question 7 needed a little bit of use of your hands. It's the right hand grip rule. So when you look at this one, the things going around it clockwise, which using my right hand, my fingers follow it around that way. So my thumb is coming out of the page. So conventional current is coming out of the page. So electron flow is into the page. So it's A or B. Since this pattern, they marry up like this pattern means that this is doing one thing and this is doing the opposite. Then you know it's B. Alternatively, you could do the same thing again and say, well, the field lines are going around that way, so my thumb's going into the page, therefore current is coming out of the page. That was question 7. Here's my logic thought train. Right hand grip rule, electron flow opposite to current, so opposite to your thumb. Look at P, thumb out of the page for an anti-clockwise, therefore the other one is, therefore current is into the page. So you say it's A or B, Q must be opposite, so you go for B, or you could do the hand rule again for Q as well as you did for P. Question 8. Here's our initial pattern. You can see the time period of them is 1. If we make the frequency less, then the time period has got to be more than 1, which means that that's the same frequency and that's the same frequency. These are less, so it's C or D, and then you're making the frequency less, so the field lines cut per second is going to be less, so power is going to be less, so it was C. Here's my thought train on that. C frequency decreases, therefore T increases. Initially T is 1 second, so now it's got to be more, which was 2, so C or D. Power will be less, therefore C. Question number 9. This thing's oscillating above the solenoid as shown. Doesn't go into the solenoid, don't be confused by that. It's not D, so it's A, B or C, and basically my logic was I had to think about what's it like at T equals 0. Do we have a current? Is it positive or negative, or do we have no current? In this scenario you have no current, because at time 0 the magnet is pulled up, which means it's at its maximum displacement, therefore minimum velocity, therefore lowest number of field lines cut per second. It's not moving through field lines at the start, is it? And then so at the initial bit there is no current, and then it starts to create a current as it comes to the equilibrium point, and then it starts to reduce to 0 as it gets to the other maximum, and so on. So A was the correct answer there. Where's my thought train for that? That was question 9. A is not D, so decide whether the start point T equals 0, maximum displacement, therefore minimum V, therefore minimum current induced, as few as field lines cut per second. And question number 10, it says it's a step-up transformer, which means that the number of coils in the secondary must be more than the number of coils in the primary, which means NP over NS has got to be a small number on top and a big number underneath. Hence, it's either A or C. If it's a step up, then voltage gets bigger, therefore current gets smaller. It's times 10 to the minus 3, it's actually going to get 1,000 times smaller, so it's going to end up being times 10 to the minus 6. We just said it was A or C, so now it's A or D, therefore the answer is A. Here's my thought train on that. Same thing, a step up means V increases, meaning more coils in secondary, blah blah blah, so A or C. V gets 1,000 times bigger, therefore current gets 1,000 times smaller. It was minus to the minus 3, therefore it's going to be to the minus 6 afterwards. The last of the multiple choice questions, question 11. So we deal with this route first, is what I did. This way round from going, or that way, sorry, P to Q, same difference. 3 capacitors in series, which means 1 over the total capacitance down this route is 1 over x plus 1 over x plus 1 over x, which is 3 over x. So this route is 3 over x, but invert it, it's x over 3. So this route is 1/3 x capacitance, and this route is x capacitance. So the total would be this route plus this route. So 1x plus 1/3 of an x gives you 4/3 x as the capacitance. Here's my mathematical proof of it. So I said that the C total is going to be this capacitance down the route, the series route, plus the capacitance down the parallel route. The capacitance down the series route is x, so 1x. The capacitance down the parallel route, 1 over that, is 1 over x plus 1 over x plus 1 over x, which means that 1 over the capacitance down the parallel route is 3 over x. So the capacitance down the parallel route is x over 3, just flip those two over. The total, capacitance total, is therefore x plus 3 plus x over 3, or x plus 1/3 x, which is 4/3 x, or 4x over 3. That's that one. Last bit, this is actually paper 2 question from November 2002. I did an answer, but then I wanted to know the breakdown for the 3 available marks. So I typed in the first sentence and it took me to Exam Wizard or something like that, and it found the question for me. So I cheekily gave myself a mark scheme. So the first mark is for identifying that the voltage in R1 is 12 and the voltage in R2 is 8. That's a mark that's worthy of a mark. So R1 voltage is 12 and R2 voltage is 8 is worth a mark. It had to be 12 because they tell you that the radio is operating at 12 volts. This route is parallel to this route. So if this is 12 volts, this is 12 volts. Total is 20, so this is 12 and this is 8. It identifies in the question that the resistances of R1 and R2 are much less than the resistance of the radio. Sorry, I'm showing you the key. It shows you that resistance R1 and R2 are much less than the resistance of the radio, which means they are going to have very, very similar currents. It means the radio has very little impact on the circuit, the potential divider setup you've got here. So basically, current here is going to be the same as current there, right? Which means V equals IR, just V and R are kind of interchangeable. So V1 over V2 would be R1 over R2. Oh, that second bit, that logic train in the middle there, that current must be similar, is worthy of a mark. Or saying something like the radios doesn't have an impact on the potential dividers is worthy of a mark. R1 over R2, 12 over 8, 3 over 2. That's your third and final mark. I suspect most people will identify this and get 1 mark, and most people will identify this and get 2 marks. Whether they would say, well, you've done this, therefore you've inferred this, I don't know. You kind of can't do this without knowing this. So I feel like if you've done this step and this step, you probably are going to get 3 marks for it. That's my thoughts on it, having never marked IB questions. And that is the first half of your test paper.